Hi everyone, Cody here. So today I'm trying to invent a water pump that has no moving parts that can wear out. This is kind of for my enclosed ecosystems that I've got, to pump water around indefinitely. And I'd really like it to be solar powered. If I had a bunch of these boxes on top of each other, and I had grass and moss and water down at the bottom, eventually the water, especially if these are connected, the water's going to migrate down. The water vapor might come back up, but salts and stuff are going to go down and get trapped, just like they do in real life, but in salty lakes. But I don't have rocks and geologic processes bringing those salts back up. So I need something to bring the salt back up. And I don't really want to use like a little pump or anything. So I was thinking what I might be able to do is make a whole bunch of real thin glass tubing, some capillary tubes, and wind them between a hot and a cold reservoir, maybe hundreds or even thousands of times, and get this to pump up. Even a single drop of salty water being pumped up every day would be enough to sustain the system. So this is my first prototype here. It's using a thermal siphon type effect, which I'm seeing if I can stack together and multiply the force that the thermal siphon can have. So I've got two glasses with water. Well, they're plastic. The water level is at the same height because water does that. It seeks the gravitational gradient that is the same. And so what's going to happen here is I'm going to heat this side and cool this side, and I'm going to see how much the water moves up on this side, if it does at all. And hopefully more than what you would expect just from a little column of warm water. Well, that was underwhelming, but it did work. You can see the, I should have used colored water. You can see there is a definite increase in the height of the water over here. And over here there is a decrease. About the same amount too, as you'd expect. In fact, if I add those two heights together, I probably get right about a centimeter. So not a whole lot. But then the height here is not very much either. Let me actually go through and calculate how much I would actually get if there was just a single loop. Okay, what we got? Looks like 40, let's call it 45 degrees centigrade there. It does have ice in it, so maybe I should just say it's 0. But it is only 0 at the top. The bottom of the jug appears to be about 5. So we've got a column height of about 140 millimeters or 14 centimeters. This here, which we will double, that's 6 millimeters, so let's call it 12 millimeters for the total displacement we got. And here's how the density of water changes with temperature. So if I had a column that was a meter tall and another column the same height, one was full of water that was 4 degrees and one was full of water that was 45 degrees, density of 1,000 kilograms per cubic meter on this, the cold side, and 990 on the warm side. That would mean that the differential over about a meter would be about 1 centimeter. So the water on the warm side would be pushed up by the cold side by about 1 centimeter, so 1 part in 100. With this, 14 centimeters, I would expect 1.4 millimeters of displacement. But I'm actually seeing 12 millimeters. So this thing does appear to work. So I've got, how many stages does this have? 1, 2, 3, 4, 5, 6, 7, 9. If I multiply the 1.4 millimeters, 0.14 centimeters times 9, look at that, 12 millimeters. It worked exactly as I thought it would. That's brilliant. I mean, I was kind of hoping to see something push the water up really high, but this is a result. Cool. Let's build a little bit larger scale version of this. So here's the larger version that I've come up with. It is 6 feet tall. It's got glass inside of a box so that the sun can heat it instead of using hot water. It's got 22 wraps of the tubing, so that's over 260 feet of this black tubing. And I'm expecting a head, well, I suppose it depends on the temperature I can get, but assuming I can get a 30-degree differential, and I should be able to get over a foot of head off this thing. So I'm just sticking it up against this so it can have a nice good view of the sun. Now, actually I have two sets of tubes in this. One that goes around 22 times, one that just goes around once. And see, the once around has already got a displacement of just under a centimeter by the looks of it. And considering that the main pump has 22 loops, I should be able to achieve 22 times this height right here. And the one that goes around 22 times, we might actually have a problem here. I used to have a bunch of air up in this line, and it's pumped that air bubble around. It's probably making the rounds already. So it does work. So the temperature of the shade behind the thing is 8.5 centigrade. Half the tubes are in the back here in the shade, right? And then half are over here in the heat. Now if I stick this thermometer in to the hot side, we can see just what this temperature differential is. That's a tight fit. I ought to ream that out. Alright, that's a little easier. Just stick that thermometer in there. Now we'll be able to see what the temperature is in there. But you can see already that the water is being pumped up at least 4 inches. That's pretty cool. It's kind of hard to see past the condensation, but it looks like the temperature is about 41.5 degrees centigrade right now. So that means I've got the 30 degrees differential that I wanted. Excellent. So yeah, we should be getting about 1% of the total column height worth of displacement. So, you know, this 4 inches is nothing for it. But of course that's the maximum displacement. I'm sure if I rose this up it would pump slower, because it has to actually heat the water more before it can finally force it through. But yeah, this 4 inches of displacement seems to be working just fine. Of course that will increase as this gets pumped down up to about, you know, probably 30 centimeters or about a foot worth of displacement once this is almost completely gone. We'll see if it's able to do that by the end of the day. I kind of have doubts. This thing is going to be really inefficient. You see, in order to pump through the amount of liquid that's in one of these tubes going up, you know, to pump that volume up, it also has to heat not only that much of the cold water, but also that much of the cold water that was on the entire back side. So in order to move just one of these volumes, which might be around 10 milliliters, it has to move 22 times as much. See, around here on back, the tubes are still very warm. See, something like almost 100 degrees there, 37 degrees centigrade. And they have to cool off, they have to radiate away their heat. And it looks like it takes all the way down to here before they get down to the temperature of the shadow. See? So not only do I have to heat the water, I also have to radiate away that heat 20 some odd times to pump just one little bit of water through. Yeah, there's a lot of room for improvement with this design. Like some sort of heat exchanger to cover the heat is definitely needed. But it still works. I'll see if it's able to pump that jar into that jar by the end of the day. I've got my time lapse set up. We'll see how it does. It looks like we're pretty much done. This shadow from the house has moved over onto it, and I think it's actually stopped pumping. It's been almost exactly an hour. It looks like we moved around 200 milliliters, give or take. Up 4-5 inches. And yes, I am aware that a solar panel this big hooked up to an electric pump could have pumped a jar full of water all the way to the top of this in a couple of seconds, but that's not the point of this test. Hope you all enjoyed. I'll see you next time. Oh, actually there is more. Okay, there's a few shrimp left, but I imagine a couple of weeks from now there won't be. One thing I found is really interesting about this is the way the algae is working is different. Even though, from the same starting material, I use the same algae starter for both of them, but the algae color and the way it behaves is completely different. Just a little bit different conditions, I guess. Like, see how this algae has grown up onto the glass here? Or this one never did that. Also, it's like a dark green color. And there's a lot more algae in this one as well, because there was a lot more carbon.